Hi there, and welcome to the course Simplifying React Error Handling. Build a robust front-end system. I am Rion Sebastian, and I am thrilled to have you here. Whether you are just starting your React journey or looking to refine your skills, this course is designed to help you simplify one of the most tedious parts of development, managing error handling code. In this course, we will tackle common challenge faced by React developers, messy, repetitive error handling code. Here is what you will learn step by step. How to centralize your API calls using Axios for cleaner and maintainable code. Build reusable service modules to separate API logic from components. Create a custom hook called useApi to efficiently manage loading, error, and data states. Use Axios Interceptors for global error handling, making your app robust and scalable. Enhance the user experience with structured feedback mechanisms for errors. As your React applications grow, writing repetitive try-catch blocks in every component can become a nightmare. Centralizing error handling not only reduces this repetition, but ensures consistency across your app, making it easier to debug and scale. By the end of this course, you will have a professional, ready-to-adapt system for managing API calls and errors, designed to be tailored to your app's specific needs. This is a hands-on course with practical examples that you can directly apply to your React projects. While the system we build is highly flexible, you can customize it further. For example, by replacing toast notifications with models or adapting error messages for specific use cases. So, are you ready to transform the way you handle API calls and errors? Let's dive into the first lecture, where we will start with a simple API call and progressively build a centralized system that you can scale and adapt for your projects. Thank you for joining me, and I'm excited to help you take your React skills to the next level. Here, I have set up two dummy APIs to fetch a product list and categories for this demonstration. Now, let's switch over to VS Code and start with the simplest scenario. A React component fetching data from an API without any error handling or loading states. Starting with this simple example helps us understand the problems we will address as we build toward better solutions. And here is a straightforward API call using Axios. And here is what's happening in this code. We are calling the API endpoint using Axios.get method inside the useEffect hook. Once we get the response, we update the product state using the setProduct function. And finally, we are displaying the product names in a simple list on the front end. Now, back into the browser, here is the output. Now, the UI might not look visually appealing. It's very basic and minimal. That's because we are focusing on the functionality for now, rather than the user experience or visual design. Pretty simple, right? This approach works fine as long as the API is reliable. But what happens if the server returns an error or the network goes down? Right now, we are not handling that at all. Now, let's simulate an error scenario next. Now, let's deliberately return a 500 response from the server that serves our dummy API data. Like this. I'm going to change this to 500 and save the changes. Now, back into the browser, reload the app, and let's see how the component reacts. See, without proper error handling, our component breaks silently and leaves the user confused. This creates a frustrating user experience and undermines trust in the application. To address this, let's add a try-catch block to handle errors. And here is what we did. We have wrapped the Axios get method call inside a try-catch block. And if the request fails, the try-catch block captures the error and logs it into the console. Now, when we reload the app, we are catching the error instead of letting it silently break. However, we are still just logging the error in the console. The user still doesn't see any feedback or know what went wrong. Let's take it a step further by adding loading and error states to improve the user experience. To improve the user experience, let's introduce loading and error states. This will allow us to show a loading message while fetching data and display a friendly error message if something goes wrong. To save time, I have already made the necessary modifications to the code by pausing the recording. And here's the updated version. We have added 3 state variables. Loading to track whether the data is being fetched. Error to store any error messages and products to hold the fetched data. And before making the API call, we set loading to true and clear any previous errors. If the API call succeeds, we update the product state. If it fails, we log the error and set a friendly error message. And finally, in the finally block, we set loading to false, ensuring the loading state is updated regardless of success or failure. So in the UI, if loading is true, we show a loading message. If there is an error, we display the error message to the user. Now, back into the browser, let's click the reload button to see the loading message when fetching data from API. See, the loading products message is displayed. Now, I'm switching back to my Node.js app and let me deliberately return a 500 response from the server again to see how our React component reacts when receiving an error response from the server. Now let's go back to the browser again and reload the app. See, the user now gets real-time feedback. Instead of staring at a blank screen, they see a message saying failed to load products. Please try again. This is a huge improvement over the silent failure we saw earlier. In a real-world app, you would probably replace the plain text with the loading spinners and more polished error messages like toast notifications or models. But here is the thing. Even though this approach works, look how much code we have written for just one API call. Managing loading, error states, and data inline quickly becomes repetitive as your codebase grows. That's why centralizing these aspects is so important. It simplifies your code and ensures consistency across components. Let's take the next step and build a better solution. The approach we discussed on the previous section works fine for small apps, but as your application scales, it quickly becomes inefficient. Let me highlight the key pain points. Number 1. Repetition. Each component duplicates the try-catch block and state management logic. Number 2. Scalability issues. Updating base URLs or error messages requires changes across multiple files. Number 3. Inconsistency. Different components may handle errors in different ways, leading to an unpredictable user experience. And these issues can make managing a growing codebase frustrating and error-prone. So, what's the solution? Centralization. By centralizing these concerns, we can simplify the code, reduce duplication, and ensure consistency across the app. So let's start by leveraging Axios to centralize our API logic. Now let's talk about centralizing Axios, a common first step to simplify API calls. Often, beginners hardcode the full API URL, including the base URL in every component. This not only violates best practices but also makes the code harder to maintain. So, the first step is creating a custom Axios instance with a predefined base URL. This way, we avoid repeating the base URL across components. And if the base URL changes, we only need to update it in one place. This aligns with the best practices, ensuring components focus solely on rendering the UI and handling user interactions. Now let's create our custom Axios instance. For that, first I'm going to create a folder named utils to place the Axios instance module. And inside that utils folder, I'm going to create Axios instance.js. Now let's create our custom Axios instance. For that, I will import the Axios module. Also, Axios provides a create method that lets us define a custom instance. This is useful because it allows us to configure settings like the base URL in one place. So I will call axios.create method here. Inside the create method, we can specify the base URL like this. And before specifying the base URL, since we are using Vite, environment variables are accessed using import.meta.env. This is slightly different from tools like Create React App, where you might use process.env. In Vite, all environment variables meant for the client must start with Vite prefix. So I will use import.meta.env.Vite underscore API underscore base underscore URL. Okay. And if the environment variable is not set, we will fall back to a default static URL. This is handy during development when you might not have all the environment variables configured. So I'm gonna cut this from here and place this as the base URL. And we need to specify the fallback URL if the environment variable is not available. So we can specify http://localhost:3000, and this is the API URL of my Node.js server, which I am currently running on my local machine to serve dummy API response. Okay, and finally, I will export this instance so it can be reused across the entire app. And here is the complete code of our custom reusable Axios instance module. Okay, and this setup ensures that the base URL is centralized and easily configurable. Whether you are working in a development, staging, or production, you can simply update the environment variable without touching the code. Now let's switch back to the product list component and replace the direct Axios import statement with the Axios instance we just created, which contains the base URL. Now I will update the API call to use the relative path /products instead of the full URL. All we have to do is simply replace this with the Axios instance module we just created, and I'm gonna delete this base URL from here. Now it contains only the relative path instead of the full URL. Okay, and here is how the updated code looks. Let's test this. I will reload the app, and as you can see, the data loads just as before. Notice how we have removed the full URL in the API call. It now only includes the relative path, thanks to the custom Axios instance. This approach simplifies our code and makes it easier to maintain. If we need to update the base URL, we only need to do it in one place. Okay. Now that we have a centralized Axios instance, we can take it on one step further by introducing service modules to organize our API logic. So let's explore that next. Now that we have a centralized Axios instance, we have cleaned up repetitive URL management, but there is still a small problem. Notice that the products list component directly configures the endpoint /products. What happens if this endpoint is needed in multiple components, or if the endpoint changes? Do we need to go into every component and update it? This is where service modules comes into play. Service modules allows us to define all API calls for a specific domain in one place. Let's create a product service module to demonstrate this. Now I'm going to create a folder named services, and this is the folder where I am planning to place all the service modules in my project. And inside this services folder, let's create a file named product services.js. Let's move the Axios instance.get function from this products list component to the product services module we just created. I will start by importing the Axios instance we created earlier. Next, I will define a function called getProducts, and this function will make the API call for fetching the product list. And here is how it looks. Now let's move back to the products list component. I'm going to copy this line from here and simply paste it here. And also don't forget to add a return keyword. And that's it. If you want to pass query parameters to the API, notice how I included params as the second argument in the get method. If we need to pass query parameters to the API, we can include them here. And this makes the function more flexible and reusable. Now similarly, I will add another function named getCategories for fetching the list of categories. I'm going to change the endpoint to /categories. Just like getProducts, getCategories will also use Axios instance.get, but point to the /categories endpoint. If needed, we can pass query parameters to it as well. Finally, I will export these functions together as part of a default object. This way, both endpoints can be easily reused across our application. And here is the complete product service module. Now, any product related API calls, whether it's fetching products or categories, are centralized in the product service. This keeps our component clean and ensures that if the endpoints or logic change in future, we only need to update the service module. Now let's update the products list component to use the product service for fetching products. First, I will remove the import Axios instance. Instead, I will import the product services. Next, in the fetch product function, I will replace axios.get/products with the product service.getProducts like this. Here is how it looks after the update. And one more thing, let me show you how to pass parameters as an object to an Axios GET request. Here, I am going to declare an object named params, which contains the category and limit. And now you can simply pass the params object into the getProduct function. Now let's take a look at the implementation of the getProduct function itself. As I mentioned earlier, when you pass an object as the second argument to the get method, Axios automatically appends the parameters as query string parameters to the URL. Okay, and this means the resulting request URL will look something like this. Now our component is simpler and doesn't need to worry about API details like the endpoint. This also demonstrates how a single service module can handle multiple endpoints. If we need categories data in another component, we can simply call product service.getCategories without repeating any logic. This approach ensures better separation of concerns. The product list component focuses solely on rendering the UI and managing interactions, while the product service handles API logic for both products and categories. If multiple components use these endpoints or if the endpoint change, we only need to update the service module, ensuring a more scalable architecture. Now that we have introduced service modules, let's take our Axios instance to the next level. It's not just for configuring a base URL. It also supports powerful features like interceptors. Let's dive into that next. Now that we have centralized API logic with a custom Axios instance and service modules, let's take it a step further by introducing Axios interceptors. Interceptors are functions that are executed for every HTTP request or response. Request interceptors can modify outgoing requests, for example, adding authentication headers. Response interceptors let us handle responses or errors globally. And in this section, we will focus on response interceptors to centralize error handling. Here we are using React Toastify, a powerful toast notifications library to display notifications. To enable notifications, we need to include a toast container component in our application. Let's add it to the app.jsx file. First, I will import the toast container component. Next, I will place the toast container at the root level of our application. This ensures that toast notifications can be displayed from anywhere in the app. Here is how it looks. Now, any toast notifications triggered in the app will be displayed correctly. Let's move on to adding interceptors. Let's start by adding a response interceptor to our Axios instance. First, I will import the toast module from React Toastify to display user-friendly notifications for errors. As a best practice, it's always important to check the official documentation to stay up to date. I have displayed the relevant section from the Axios documentation on the screen for reference. Axios provides the interceptors.response.use method, which takes two arguments: a success handler for processing successful responses, and error handler for managing failed responses. Let's define the success handler first. For now, I will log the successful response to the console and return it unchanged. And now, let's move to the error handler. I will check if the error has a response property. If it does, I can access the HTTP status code from error.response.status to handle specific errors differently. And here is how we will structure the interceptor. Next, I will provide tailored error messages for specific status codes. To save time, I paused the recording and made the necessary code modifications. And here is the updated version. For specific status codes like 403, 401 and 500, we now provide tailored error messages. For example, a 401 status code redirects the user to the login page. A 403 status indicates forbidden access, while a 500 status reflects a server error. And we display appropriate messages for each scenario. If the error has no response, we assume it's a network issue and notify the user with a message prompting them to check their internet connection. In a real-world production application, it's better to use the redirection mechanics provided by React Router DOM, such as programmatic navigation to handle redirections. The use of window.location.href in this example is for simplicity and demonstration purposes only. Additionally, there might be cases where the frontend needs to display error messages returned from the server. The interceptor can be updated to check for a server-provided error message. For example, you can check error.response.data.message and display if it is available. Otherwise, it falls back to the customized error messages. We are also using a toast notification system to provide immediate feedback to the user by displaying these error messages. And finally, we call promise.reject to reject the promise with a custom error message. This ensures that components or hooks using Axios can consistently handle errors, providing better maintainability and flexibility across the application. In production apps, there is definitely a need to balance error visibility with usability. While toast notifications are great for transient issues like network errors, more persistent or critical errors might require different handling. For example, you might show inline messages, redirect users, or use modal dialogues depending on the context. And this guide demonstrates a centralized, consistent structure for managing errors, but it's essential to evaluate and adapt it based on your application's specific needs. For instance, you could route errors to various UI components based on their type or severity. Now let's briefly talk about how this integrates with promises. Axios returns a promise that either resolves or rejects. By rejecting the promise with a custom error message, we ensure consistency in how errors are handled. For example, in a component or custom hook using Axios, you can access this custom message through the error.message property. And here's a quick example. This approach ensures that errors are handled predictably and consistently throughout the app. By using a custom error message in the catch block, you maintain flexibility to display error-specific feedback to the user. Now in the previous example, we have hard-coded the error message failed to load products, please try again directly into the setError function. Instead of using a static message, I am going to replace it with the error.message property so that the error message dynamically reflects what we receive from the server, and here is the updated code. Now let's see how this works in action. I am switching over to our Node.js application which currently returns dummy API data, and this time I will deliberately return a for node 3 error to simulate a scenario where access is forbidden or the user's session has expired. Now let's move back to the browser, and there it is. The toast notification now displays the appropriate error message we configured earlier in the Axios interceptor for a for node 3 status code. Also, notice how the error message is displayed dynamically in the UI label. This message is coming directly from the promise we returned in the Axios interceptor. Perfect. Now, coming back to the Axios instance, we need a minor enhancement. Can you guess what? Let's centralize our error messages into a single file. This approach keeps our codebase cleaner and makes updating error messages more manageable. No more hard-coded messages scattered across multiple files. First, I'm going to create a folder named config. And inside this folder, I will create a file called errormessages.js. And this file is used to store our error messages. And here is the updated code. Now, all our error messages are managed from a single source of truth. This not only keeps our code organized, but also makes it easier to update error messages consistently across the application. Next, I will integrate this file into our Axios interceptor. To save time, I paused the recording and made the necessary updates. Let me show you the changes. Here is what we have done. The interceptor now pulls error messages from the centralized error messages file. For specific status codes like for node 1 or for node 3, we provide tailored feedback to the user, while unknown status codes fall back to a generic error message. If no response is available, we assume a network issue and notify the user to check their connection. This keeps the interceptor focused on managing error messages and notifying users. Redirection logic or other application level concerns can be handled separately for better modularity and maintainability. Now let's go back to the browser and reload the app to check if everything works as before. Perfect. The application works exactly as expected. By centralizing error messages, we have eliminated duplication and improved consistency across the codebase. Updating error messages now requires changes only in the errormessages.js file. This approach scales well and ensures that any adjustments to error handling logic are handled quickly and efficiently. But we are not stopping here. With interceptors in place, we have taken our centralized Axios instance to the next level. Next, let's explore how we can build a custom hook to manage API calls, further simplifying our components and taking reusability to the next level. Already created a reusable Axios instance, introduced a global error handling mechanism, and centralized API calls in service modules. But there is still one issue. Our components are directly managing loading, error, and data states. While try-catch blocks work, do we really want to repeat this logic in every component? As our application grows, this repetition can lead to bloated components. inconsistent implementations, and maintenance headache. So let's navigate to the product list component. Looking at the current code, if we need to make another API call here or in a different component, we might copy and paste the entire block of logic, only changing the service function call. So every time we handle an API request, we are repeating the same logic, such as managing loading states, catching errors, and storing data. The only unique part is the API function itself, like product service.getProducts. So this repetition is a perfect use case for custom hooks. A custom hook in React is simply a JavaScript function that starts with the keyword use. It lets us extract reusable logic and share it across multiple components. For example, instead of duplicating state management for API calls in every component, we can move it to a custom hook like useApi. This ensures consistency and simplifies our components. If you are new to hooks, don't worry. I will explain each step as we build this custom hook together. To start, I will create a folder named hooks, and under this folder, I will add a file called useapi.js. Our goal is to move all the repetitive logic like managing loading, error, and data states into this hook. Let's define the structure of the hook. The useApi hook will be a function that accepts the following argument: service function. This is the service module function we will call to fetch data from the API. Let's start by importing the useState hook from React, as we need state variables to manage our API responses and request states. Inside the hook, we will define three state variables using useState. Data, this will hold the API response data. Loading, this Boolean state tracks whether the API request is in progress. And finally, error. This will store any error messages encountered during the API call. And here is the explanation of state variables. Data is initialized as null because we haven't fetched anything yet. When the API call succeeds, we will update this state with the response data. Loading state is initialized as false because the API request has not started yet. Error is initialized as null since there are no errors when the hook is first used. Next, we will define the request method. This is where the API call happens. The request method is an asynchronous function allowing us to handle the promise returned by the service function using await. It also accepts args, a REST parameter that allows us to pass any arguments to the service function. For example, if the API function expects query parameters or a request body, we can pass them here. To make this hook practical, I will move the repetitive logic from the product list component. Let's copy the code block from the fetch products function. Paste it into the request method and replace product service.getProducts with the service function. This makes the hook dynamic and reusable for any API function. Lastly, I will replace setProducts with setData to update the data state. At the end of the useApi hook, we return an object containing data, loading, error, and request. This is important for two reasons. Number one, data exposure. By returning these values and functions, we make them accessible to any component that uses the useApi hook. Number two, separation of concerns. The hook handles all the API logic internally, but it exposes only what the component needs, such as data, the API response ready for rendering, loading, to display a loading indicator while the API request is in progress, error, to show any error messages to the user, and finally, request, a method to trigger the API call, keeping the hook dynamic and reusable. This way, the component can focus solely on the UI without worrying about how the data is fetched or managed. To summarize, here is what the useApi hook does. It accepts an API function like productService.getProducts. It manages three state variables: data for storing the API response, loading to track whether the API request is in progress, error to store any error messages, and the request function sets loading to true and clears any previous errors, calls the API function to update the data state if the request succeeds, handles errors and updates the error state if the request fails, resets loading to false once the API call is complete. With this, we have built a reusable hook that manages API call, loading states, and error handling all in one place. Now, let's simplify the product component by using useApi custom hook. First, I will import the useApi custom hook into the product list component. I am going to delete the local state variables that used to hold the API response data, loading state, and error state in the products list component. These variables are now managed by useApi since the logic has been moved into the useApi custom hook. And I will destructure the values returned by useApi, such as data, loading, error, and request. And I am going to pass productServices.getProducts as the argument to the useApi function. The destructured data is renamed to products for clarity since we are fetching product data here. Similarly, loading and error are used for conditionally rendering loading indicators and error messages. And finally, the request function triggers the API call, keeping the component lean and focused on rendering the UI. I will delete the fetch products function because we no longer need it. Instead, I will call the request method from the useApi hook inside the useEffect. Some of you might be wondering how the service function argument in the useApi hook is accessible inside the request method. This is a great example of closures in JavaScript. Closures allow an inner function to access variables from its outer function even after the outer function has finished executing. Here, service function is passed to the useApi function and remains accessible inside the request method because of closures. This makes the hook dynamic and reusable for any API function you pass to it. And we are making a basic request with no parameters. As you can see, when the component mounts, we call request inside a useEffect. This fetches our products without any specific parameters. But what if we need to fetch a filtered list? Maybe we want to limit results or filter by category. Our request function can accept an object of parameters and pass it along to our service call. Let's do that. Now, I will update our use effect so that request is called with a payload. For instance, let's fetch only electronics limited to 10 items. Now, when product list mounts, it will pass category electronics and limit 10 to the get products call in our service module. To clarify, here is our product service.getProducts function. Notice how it accepts params and forwards them to our Axios instance. This means any object we pass to request ends up here as the second argument, automatically appending category equal to electronics and limit equal to 10 to our URL or whatever parameters we specify. In our product service module, we are demonstrating a GET request. But the same pattern applies to any HTTP method like post, put, patch, delete, etc. You simply change the Axios method to the one you need and pass any required parameters or data. Because we are using our centralized Axios instance, all these requests will still benefit from the same base URL, interceptors, and error handling logic. Now that we have seen how to trigger a request from our product list component, let's briefly walk through the flow to ensure everything is clear. When the component mounts, we call request from our custom hook useApi. Inside the useApi, the request function invokes our service module method. In our case, the request method invokes the service module product service.getProducts. The module uses our centralized Axios instance to call the actual endpoint. In a GET request, it appends params as query parameters. For post or put, it sends data in the request body. The Axios instance automatically prefixes the base URL and runs through interceptors for global error handling. If something goes wrong, the error is processed here first. The service module then returns a promise which useApi awaits in a try-catch block. If successful, the result data updates the data state. If there is an error, we catch and handle it. At the end of this chain, our React component receives clean data or an error message, leaving the component itself responsible only for presentation and user interactions. This is what makes our approach scalable, maintainable, and easy to reason about it. When iterating an array in React, it's always a good practice to use optional chaining with map method. This ensures that if the product array is null or undefined, the map function won't throw any error. Let me show you how that looks. Now let's go back to the browser, reload the app, and check if everything works as before. Perfect. The app works exactly as expected, and the component is now cleaner and more maintainable. By using useApi, we have centralized redundant logic into a reusable hook. This ensures consistency across the app and makes the codebase easier to scale. The beauty of this hook is its flexibility. By passing any service function and arguments, you can use it with different endpoints, request types, or payloads. Look how much cleaner this is. By using useApi, we centralize error handling logic as well. We don't see any base URLs, no inline error handling. Without this setup, every component would need its own try-catch block. leading to repetitive and inconsistent code. All that logic has been centralized. Also, a custom hook like useApi can be customized for different APIs and extended with advanced features like retries, making it incredibly flexible. The product list component now focuses solely on the UI, which is a main benefit of separation of concerns. Before we wrap up, let's connect the dots and visualize how all the pieces we have implemented fit together. When a component initiates an API call using useApi, here is the flow that gets triggered. Components interact with service modules like productService.getProducts. These modules act as the gateway to specific endpoints and rely solely on the centralized Axios instance. When useApi is called, it takes a service function as input. This request method inside useApi triggers the service function, which in turn makes the HTTP request via the centralized Axios instance. The Axios interceptors act as a centralized error manager. They log errors, pass predefined error messages, and even handle actions like redirecting users on authentication errors. By returning structured responses, useApi abstract away the complexities of managing API calls, allowing components to focus purely on rendering and interactions. This flow connects all the components of the centralized error handling system. The component triggers an API call using useApi. useApi calls the service module, passing any necessary parameters. The service module uses the Axios instance to make the HTTP request. Axios interceptors handle the response or parse errors, logging them and notifying the user if needed. Finally, the useApi hook returns structured states back to the component. This flow ensures that components focus on rendering data and interactions. Error handling is centralized and consistent. API logic is abstracted, reducing repetition and improving maintainability. By combining React's hook with Axios interceptor, service modules, and a centralized error management system, we have built an architecture that scales beautifully with your app. In upcoming videos, we will dive deeper into adding sophisticated error categorization and logging to better track and debug issues, implementing retry logic for transient errors, ensuring a smoother user experience during temporary outages, canceling requests to prevent memory leaks when components unmount, a critical feature for robust applications, enhancing user notifications with custom toast styles or models for more interactive feedback. We will also explore how to extend useApi with advanced features like custom retries and detailed analytics. Congratulations! You have completed the course Simplifying React Error Handling, Build a Robust Front-End System. I hope this journey has been as exciting and insightful for you as it was for me to create. You have learned how to centralize API calls using Axios, implement global error handling with interceptors, create reusable service modules for clean and modular API logic, build a custom hook to manage API states efficiently, enhance user feedback with structured error handling techniques. These skills are not only valuable for improving your React projects, but are also essential for writing scalable and maintainable code in real-world applications. Before we wrap up, here are some steps you can take to continue your learning journey. You can practice what you have learned so far by applying these techniques to your own projects or explore new APIs to integrate. You can also explore advanced topics like retry mechanisms, request cancellations, and analytics integrations to further enhance your error handling system. Stay connected with me for more tutorials and updates on future course. If you enjoyed the course or found it helpful, please take a moment to leave a review. Your feedback not only helps me improve but also guides other learners in finding this course. Thank you so much for choosing to learn with me. Whether this is your first step into advanced React concepts or one of many along your development journey, I'm thrilled to have been a part of it. Keep building, keep learning, and keep coding. See you in the next course. Happy coding!